In this next part, we're going to talk about how you evaluate polynomials. So if you remember back to our unit on linear expressions, we evaluated linear expressions by taking a number that they told us was going to be equal to the variable, substituting it in for the variable, and then using order of operations to solve the linear expression. Well, those rules haven't changed with polynomials. It's going to be exactly the same thing. So as a way of explaining it, just say the same way we evaluated linear expressions. And that way is to substitute in values, then follow order of operations, to simplify. So in our first example, we have evaluate the trinomial y squared minus 10y plus 3. For 69, we're going to do that when y is equal to 4. So I'm going to rewrite this expression, y squared minus 10y plus 3, substituting in a 4 for the y. So it's going to become 4 squared minus 10 times 4 plus 3. Using order of operations, I want to complete the exponents first. So 4 squared is 16. Then the multiplication, 10 times 4 is 40. And then just bring the plus 3 down. Then in the next step, 16 take away 40 is going to give me a negative 24. And when I add 3, I get negative 21 as my final answer. Doing the same thing when y is equal to a negative 1, I have y squared minus 10y plus 3 again, but in place of the y, I'm going to put the integer negative 1. So it becomes negative 1 squared minus 10 times negative 1 plus 3. When I square a negative 1, it becomes positive 1. A negative 10 times a negative 1 is going to give me a positive 10 plus 3 more. 1 plus 10 is 11, plus 3 more gives me a final answer of 14. Let's talk about the rules for adding and subtracting polynomials too, since we're only at 3 minutes, and then we'll do the examples in the next video. So when you want to add or subtract polynomials together, for adding, remove parentheses, then combine like terms. And then you write your final answer in descending order of degrees. If you're subtracting polynomials, you need to first distribute the subtraction to every term in the polynomial that's being subtracted. Okay? And once you've distributed that negative over the polynomial that comes behind it, then you're just going to follow the same rules that you followed for adding.